Good morning, guys. This is Arnab Chaudhary from VIT Bhopal, and today we are working on like an interesting problem. You can see the problem is inserting an element at the bottom of a stack. So, what is a stack? Stack is like a data structure, and in that data structure, you have to put the, there new element. You have to take the input from the user and put a new element at the bottom of a stack. So the problem has a lot of possibilities to be done, but right now what we are going to focus is the given template. Over here at GeekForGeeks, the template is we have to use a stack, and there's a function known as the insert at bottom, and the parameters of the function include stack, which is taking us stack at integer data type, and the name of that stack is defined as st, and the element which has to be inserted is int x. So we have to see the question once. See, the question is insert an element at the bottom of a stack. You are given a stack st of n integers and an element x. You have to insert x at the bottom of the given stack. So note that everywhere in this problem, the bottommost element of the stack is shown first while printing the stack. For example, the input is given as n equals to 5, which is the size of the stack, and x equals to 2 is the element to be inserted at the bottom of the stack, and the stack is given as 43218. So you can see 43218, the element to be inserted is 2. So the output will be 243218. So explanation is like this, that after insertion of the second element or the element 2, the final stack will be 243218. Let's take an example 2. The example 2 is like n equals to 3, x equals to 4, which is n is the size of the stack, which is 3, x equals to 4. So 4 value we have to insert in front of the stack, or known as the bottom of the stack. So st equals to, the output will be 45321. So the task is you don't need to read, input, or print anything. So while solving problems in Geek4Geeks, also last previous two problems, the first problem which we solved include a binary search tree problem, and the second problem we solved includes Fibonacci till the nth term problem. In both of the problem, you have noticed one thing, that we don't have to take the input from the user. So the input from the user doesn't need to be taken, as it's a built-in function with a given template insert at bottom, which takes a stack st and then as an integer x as input returns the modified stack after insertion. You can see the expected time complexity is big O of n, and the auxiliary space complexity is big O of n. Also, yeah. So let's start the problem. So we can see that the class solution public stack integer answer at bottom. So given a stack, you can see that the method is already defined. So what we are going to do is we are going to check whether the stack is empty. So now we have to check if st, the name of the stack, is empty. So it's a built-in function is empty, and is empty is true, then we have to return st, and before that what we have to do is we have to push an element x. So basically, given a stack which has no elements inside it, that is the first test case we are going to check if it has no element inside it. So we have to first put a first element inside it. Otherwise, how will you do? Because you can see that if the stack is empty and there is no bottom element practically, but user is giving an element x, so where will you put this element x? You have to put it. So that's why we are using st dot push, and in first bracket we will use x, which is like we are putting the first element of the stack. So now let's come to the else part. In the else block, what we are going to basically do is we are going to make a temporary variable temp, which will pop the bottom or the last element of the stack. So how you're going to do this is like int temp equals to st dot pop and st dot pop. Yeah, so we are storing the last element. So what now left is we have to recursively call this function, because every time you see the user will put a value, like a stack gets updated from the user. Okay, so I can't show you the user defined part over here, but I will definitely switch my screen and show you the path in a IntelliJ environment, where I will take the input from the user and execute it, and you will get to understand why the function is recursively called. So insert at bottom. So we have to again recursively call this function insert at. So what is recursively calling function? So recursively calling function is a function which calls itself. It works like a loop, and it is the best possible way to optimize this problem, and it will give you a way better, like faster time complexity as expected big of n. So in this we are going to pass two parameters, st comma x, and you can see that the parameters which we have passed is insert st comma x, because in the template of that function there are only two parameters which can be passed, which is st and x. So once these two functions are passed, now we are going to push the element, which is a temporary element. So temporary element, how we will push, st dot push, and while pushing we will pass the temporary variable. So once the temporary variable is passed, now we have to finally return the new updated linked list. Oh, sorry, linked list, the stack. So the new updated stack is return st. So the else block gets closed. Then you can see the public stack block gets closed, and finally the class block gets closed. One thing I'm missing over here, since we are dealing with stack, which is a library, so we have to, like data structure present in a library of the util package, we have to call that import java dot util dot star semicolon, or you can use java dot util dot stack. Let's compile it and see if there's any problem. So we can see that there is a compiler error. The compiler error is import java dot in class util. So I don't think in this library, in this gfg, we have to import a class. So let's try without it only. So yeah, the request is queued, ready for evaluation. Oops, return rt. No, sorry, this is a spelling mistake. It should be st. Let's do it again. Compile. Queuing. Sometimes the queue can be very tedious. So meanwhile it is queuing, let's discuss like the problem. So like you can see now, the input is 234215, the output is 4215, and the expected output is also 4215. So let's submit the question and see for the evaluation of the test cases whether we passed it. We will get one geek big bonus. Geek big. So it's a geek, like, okay, leave that. So this is a coin. So this coin is very helpful, and it has some. It's like whenever you solve a problem, you will get one geek bit. So what geek byte problem basically does is, like, it counts the number of streaks you have. It also acts as a reserve. If you by chance miss any streak or challenge, that time you can use the time machine, but also using the time machine requires a lot of gig bits. It's like 60 gig bits. So in order to get 60 gig bits, you need to solve around, say, 60 days. But tell you a trick. You don't actually have to solve 60 days in order to get 60 gig bits. So what basically you have to do is you have to be consistent enough every day, solving one problem a day in GFG, and you will get bonus 8 gig bits on the Friday or the last day of the week. So on that particular day, you will get 8 gig bits. So for the initial 8 days, you will get 8 gig bits. And after completing the 8th day, you will also get 8 gig bits. So total adding up to 16 gig bits a week. Similarly, if you be consistent enough for 4 weeks, you can easily get a lot of gig bits. And later on, these geek beats can be added up in GFG. You can redeem your geek beats by using it for as a time machine to go back to a previously missed challenge, or you can use the geek beat for buying a merch like a Geek for Geeks t-shirt or Geek for Geek bags. So yes, I hope you liked today's problem, and now we will show you how to deal with this problem in the. Hello, so guys, we can see that this is the class solution, public stack integer, as discussed earlier. So what now we are going to do is we're going to make a main method for this function. So for this function, how we're going to take user defined value. So public static void main. So in this method, we will pass the values. So in public static void main is we're going to pass the values. So let's say scanner class, we have to define scanner system in. Now we're going to define the stack. So how is going to stack look like? We have to check. So the stack is pretty much going to be like we have to take stack integer data type, a new stack, and the number of elements of the stack, and also take print the number of elements of the stack. So let's define the stack. So it will be stack like integer abc equals to new stack, and use new stack. Yeah. So now we have to take the input the number of the elements from the stack as well. So it will be like system dot out, and then enter the stack. So when we have entered the number of elements of the stack, so int n equals to sc dot next named for loop enter, and initial dot push. We have to push the value, uh, say I. Yeah, wait, let me check what the syntax of this. That's the syntax should be put. Yeah, we have to just push the elements of that, and yeah, not much of a problem. Yeah, sc dot next. So we can see the stack defining is complete. Now let's system dot out dot get the element the int equals to sc dot next, and then we have to make an object of the class. So bottom element is the name of the bottom element. So we have to call element of a bottom element of a dot the insert at bottom. Um, we have to pass a b c and x. Pass the bottom of the elements. Let's try and print this object. Um, so let's try to compile this. Some error. Where's the error? Let me check it. Mm, the error must be over here. We have abc dot push. Um, So then error should be stack integer st equals to abc equals to new stack. Did I close the first bracket, open, close? Yeah, I missed that. Now let's compile it. Yeah, number of elements of a stack, say 4, 10, 12, 13, 14, 6, 6, 10, 20, 12, 13, 14. Yes, so it's working. So let's guys just see. First we have to make a main method.